Right, today's video, we're going to learn how to solve trigonometry equation. So we have learned how to sketch sine curve, cosine curve, and tangent curve. So I'm going to use the shapes of this curve to explain how we can go about solving trigonometrical equations. Let's start off by looking at the sine curve. So on the screen, you will see the sine curve. Right, on the x-axis, I'm going to label it with the letter x. On the y-axis is the letter y. So the name of this curve is y equals to sine x. All right, so x represents the angle on the x-axis and y represents the value for your trigo ratio. So if you look at, for example, if your angle is 50 degrees, okay, you draw a vertical line and then from there project it to the y-axis. That will be the value for sine 50. So what we're going to do now is we're going to solve these equations. Sine x equals to 0.5. We want to find out what are the possible angles of x that will give us the ratio 0.5. So in other words, I need to draw a horizontal line. Okay, if you were to compare, then I need to draw a horizontal line y equals to 0.5. Okay, and the intersection points will give me the angles that will give us the ratio 0.5. So this is what we're going to do. So I'm going to draw a horizontal line. Y equals to 0.5. Right. So what are the possible angles? Let's look at the positive angle first. You have one value here, and that happens to be 30 degrees. So sine 30 will give me 0.5. And then I have another values here, another intersection point here, 150. So sine 150 will also give me 0.5. So in other words, sine 30 degrees give me 0.5. Sine 150 also give me 0.5. So if I'm asked to solve this equation, sine x equals to 0.5, then the possible angle will be 30 and 150 for the positive angle between 0 and 360. We just consider one cycle first, easier. Right, so where is this angle 30 from? Which quadrant is that? It's from the first quadrant. So in other words, angle like anything that is below between 0 to 90, all right, will give you a positive ratio. And angles between 90 to 180 will also give me a positive ratio for sine functions. Okay, so how about the negative angles then? For the negative angles, then which are the quadrants that will give us the positive value of x? So if you look at the left hand side, okay, this intersection point actually come from the fourth quadrant of your negative angle. One, two, three, four. This is the fourth. This one is the fourth one, sorry. And this one here, this is the third quadrant. So for the negative angles, right, for sine ratio to be positive, the answer will come from the third and the fourth quadrants. And then for the positive angles, for sine ratio to be positive, the possible values of x will come from the first and the second quadrant. All right, so let's look at what happened if I want to solve for sine x equals to negative 0.5. So what are the positive, or where do you think the answers, which quadrants do you think the values of x can come from? So if you look at the diagram here, okay, the first intersection point is this point here. So that would be your third quadrant. Then the second intersection point here, okay, will come from the fourth quadrant. So for the negative angles, right, it will come from your first quadrant and the second quadrant. So in summary, if you're solving for sine theta equals to a negative number, you're finding a negative number for sine theta, then the angle theta will come from the third and the fourth quadrants for angles measured in the positive direction, and first and second quadrant for angles measured in the negative direction. Right, let's do the same for solving for cosine theta equals to a positive value. Right, so where would the answer theta come from? Which quadrants? First quadrant here, and the fourth quadrant. For the negative angles, first and fourth. All right, so now we're going to examine the cosine curve. So let's start off by having a cosine curve. So on the x-axis, we're going to label it as x, and then on the y-axis is y. And we're going to solve for cosine x equals to negative 0.5. All right, so where is the first intersection point? This one here. So which quadrant is that? It's the second quadrant. The second intersection point here will come from which quadrants? The third quadrant. How about the negative angle? Right, so to summarize, if you're solving for cosine theta equals to a negative value, then the angle theta, right, will come from the second and third quadrants for angles measured in the positive direction, and second and third quadrant for angles measured in the negative direction. Right, let's move on to the tangent curve. So if you're solving for tangent theta equals to the positive values, okay, let's look at where the intersection points are. Right, so it will come from the first quadrant, or the third quadrant. For the negative one, come from the second or the fourth. All right, let's see what happens if we're solving for tangent theta equals to the negative value. Okay, the first intersection point comes from the second quadrant. Second intersection point comes from the fourth quadrant. For angle measured in the negative direction, will be first and third. Right, so in summary, if you start off with a unit circle, right, with the angles measured in a anti-clockwise direction, we're talking about positive angles. Right, in the first quadrant, that is between 0 degrees to 90 degrees, right, the trigonometrical ratio of any angles in the first quadrant will give you a positive value. Meaning, if I just select one angle that is, let's say, 50 degrees, so sine 50 will give you a positive value, cosine 50 will give you a positive value, tangent 50 will give you a positive value. Okay, that is in the first quadrant. And then in the second quadrant, which is between 90 degrees to 180 degrees, right, only the sine ratio will be a positive value. In other words, if I give an example, like let's say 120 degrees, so sine 120 will be positive, but cosine 120 will be negative, tangent 120 will be negative. And in the third quadrant, which is between 180 to 270, right, only tangent will give you a positive value. Sine and cosine will be negative. And in the fourth quadrant, right, only cosine it's positive. Fourth quadrant will be between 270 to 360. Okay, so to remember that, right, A, what does A means? A means the trigonometrical ratio of any angles in the first quadrant will be all positive. All positive, that's A. Second quadrant, only sine will be positive. Third quadrant, tangent will be positive. And fourth quadrant, only cosine will be positive. The trigonometric ratio. So one way to remember this, it's you can say add sugar to coffee. So how about angles that it's measured in a clockwise direction? Angle that's measured in the clockwise direction refers to the negative angle. So how does the trigonometric ratio behave? Okay, it's actually the same way. It behaves in the same way as the positive angles. That means, but the only difference is when you talk about negative angle, this one become the first quadrant, second, third, and fourth. Okay, the way you label the quadrants will be different. So in other words, for the positive angle, right, for positive angle, for sine ratio to be positive, it comes from the second quadrant. But if you talk about negative angle, it comes from the third quadrant. But if you look at it this way, actually they refer to the same portion here. Right, so after learning all those things, the questions to ask is that how do we solve trigonometry equations? It seems like very confusing, right? It's like, is it every time you need to draw the graphs and then you find the intersection point? But the answer is no, that is a way to do it. So supposing I want to solve for sine x equals to 0.5, okay? And what are the positive values of x to get the ratio 0.5? So this is what we have done earlier on, right? The first angle will be, this will be your first value, first intersection point. Second intersection point, third, so on and so forth, second. Right, so the first value you get is 30 degrees. The second value is 150. Right, so how do you get 150? 150 is when you take 180 minus away the first angle. So the first angle is very important. The first angle is called the reference angle or the basic angle. So your first angle here is 30 degrees. So to get the second angle is 180 minus away your first angle, 150. So that's for the positive angle. So for the negative angle, right, for the negative angle, it's a bit confusing. Remember, this is called the third quadrant. Right. So the third quadrant, it's 180 plus your reference angle. But because if you're dealing with negative, you have to put a negative in front of it. And then for this intersection point, how do you get the answer? That is, you take 360 minus away your alpha, and with the negative in front of the brackets. All right, so to solve for sine x equals to negative 0.5, what we do is that you have to find the reference of the basic angle first. And the reference of the basic angle is actually a angle that is a cube, that is between 0 to 90, is a cube angle. Right, so to find that alpha, you have to ignore the negative sign here, just sine inverse 0.5, which gives you 30 degrees. So that will be your reference angle. Okay, so your first answer will come from here, which is 180 plus alpha. Second answer will be 360 minus alpha for the positive angles. Negative angles will come from your first quadrant, which is just negative the basic angle, which is 30, so negative 30. So in other words, sine bracket negative 30 will give you negative 0.5. Then the second answer will come from the second quadrant. Okay, you just make sure you have a negative in front of your brackets because you're dealing with negative angles. So in summary, if you want to solve any trigonometry equations, we need to find the basic angle or the reference angle first. Okay, the name of this basic or the reference angle is called alpha. Okay, this is called alpha. Right, so what are the steps involved? For positive angle measured in anti-clockwise direction, if the angle is from the first quadrant, that means your answer theta will just be equals to your basic angle alpha. If it's from the second, then the second possible values of theta will be 180 minus alpha. If the angle is from the third quadrant, it's 180 plus alpha. If the angle is from the fourth quadrant, it's 360 minus alpha. Right, so if you're talking about angles, negative angles, that means angles measured in a clockwise direction. Okay, so if the angle is from the first quadrant, then basically your angle theta is just negative alpha. If the angle is from the second quadrant, this will be your first, second, third, fourth. Then for this angle from the second quadrant, it will just be negative bracket 180 minus alpha. From the third quadrant will be negative 180 plus alpha. For the fourth one will be 360 degrees, negative bracket 360 minus alpha. So if you were to compare the angle measured in a anti-clockwise versus a clockwise, the only difference is for angles measured in the clockwise direction, you just make sure that you put a negative in front of your brackets. Okay, for angles measured in anti-clockwise, you don't need the negative sign there. Right, as the saying goes, a picture tells 1,000 words. So I'm going to show you how, in picture form, the concepts we have learned. So let us start off by having a unit circle with the x and y axis. Right, so if your answer is from the first quadrant, then the angle theta will just be alpha. But if the angle has to come from the second quadrant, right, then the values will be, the theta will be 180 minus alpha. If it's from the third quadrant, it will be 180 plus alpha. If the answer is from the fourth quadrant, that will be 360 minus alpha. So it's pretty easy to remember. Right, so for the angles that is taken from the clockwise direction, meaning the negative angles, right, then how does it look like? So if your answer is from the first quadrants of the negative angle, okay, angle measured in the clockwise direction, then the theta will just be negative alpha, because we're dealing with negative angle, so you have to put the negative in front of your alpha. And if it's from the second quadrant, it's negative bracket 180 minus alpha. From the third quadrant, it's negative bracket 180 plus alpha. And from the fourth quadrant, it's negative bracket 360 minus alpha. It appears that all these concepts are rather confusing, like first quadrant, second quadrant, that kind of thing. So we're going to solve equations and apply what we have learned. So that's solve this equation, sin x equals to 2/3, and the range, meaning the answers must come from 0 to 360. Right. The range we will have to consider the possible values of x will be between 0 to 360. So step 1, we have to find alpha. Alpha is very important. We have to find alpha. So sin x is equals to 2/3. So alpha will be sin inverse 2/3, which is 41.81 degrees. Right, so step 2, determine which quadrants the angle should come from. Right, so your 2/3 is a positive value. 2/3 is a positive value. So recall our add sugar to coffee. So for sin ratio to be positive, okay, it will come from the first quadrant. A meaning all the trigo ratio will be positive, and it will come from the second quadrant. S meaning the sine angle will be positive. So your answer for x will have to come from the first and the second. So for the first quadrant is easy. Your angle x will just be alpha. All right, so that's easy. From the first quadrant, your angle x will just be alpha. Then from the second quadrant, it will be 180 minus alpha. So 180 minus 41.81, 138.2. So this is how you apply what we've learned to solve a trigo equation. Right, what happens if it's a negative value for sine x? We still do the same steps, meaning we still have to find our alpha. But in this case here, remember alpha, it's an angle, it's an acute angle, right? So sine alpha will be a positive value. So hence, even though you have sine x equals to negative 0.4, you have to ignore the negative sign first. And it's just sine inverse 0.4. So that is your alpha. Right, then the next step is, remember your ASTC again. Okay, so for sine to be negative, the angle x will come from the third and the fourth. Okay, that's what we have written there. Because sine x is negative 0.4, so the answer will come from the third and the fourth. So if you do not understand why it comes from third and the fourth, go back and revisit the earlier slides that I've shown you using the sine curve to explain. So for the third quadrant, you just be alpha plus 180. So it's 23.58 plus 180. And then for the fourth quadrant, will be 360 minus alpha, which is 360 minus 23.58. So this is how you solve the trigo equation sine x equals to negative 0.4. So let's do one question involving negative angle. Right, so the range we have to consider will be between 0 degrees to negative 360, which means what we'll be considering will be the angle taken in a clockwise direction. Right, so step one, as usual, we have to find alpha. So alpha will just be cosine inverse 2/3, give you 48.91. All right, then step two, we have to determine which quadrant your cosine x is a positive value. Okay, so if you look at the diagram that I've just drawn, for cosine x to be a positive value, it will come from the first quadrant and the fourth quadrant. Okay, you come from the first quadrant and the fourth quadrant for angle measure in a clockwise direction. All right, that's what I've written there. Okay, so that's find the first angle. So for the first quadrant, then your angle x will just be negative alpha. And then for the fourth quadrant will be negative bracket 360 minus alpha. Right, so this is how you solve a trigo equations where the range that you need to take is from the angle measure in the clockwise direction. Right, let's do harder questions. In this case here, you can see that you're not solving just for sine x or cosine x. You're solving for sine bracket 2x minus 15 degrees. So this is a rather difficult questions. But the steps involved are still the same. Except that now we have to find the new range. Okay, what do we mean? If you're just solving for sine x, then x is between 0 to 360. That's no problem. But because right now I'm actually solving for 2x minus 15. So I would have to find the new range now. Okay. Ultimately, I need to find the values of x between 0 to 360. But before I can arrive at that point, I need to find the range for 2x minus 15 degrees first. Okay, so if x is between 0 to 360, 2x will be between 0 to 720. 2x minus 15 will be between negative 15 to 705. So in this case here, right, what we are saying is if you consider angle measure in the anti-clockwise, then you will have to consider 2 rounds. And if you talk about angle measured in a clockwise direction, then you just have to consider this quadrant. All right, so step 1, as usual, find, now is step 2, find your alpha. Okay, so if you make sine functions the subject, you will get negative half. So to find alpha, remember we have to ignore the negative sign, just sine inverse half. So your alpha is 30 degrees. Your alpha is 30 degrees. Right, step 3, we have to find the quadrants where your sine, the values of x should come from. And because we're dealing with sine ratio, sine 2x minus 15 to be a negative half. So negative half, remember you add sugar to coffee, negative will come from your third and the fourth quadrants. Okay, so the third quadrant will be 180 plus alpha, which is 180 plus 30, 210. That is the third quadrant. And the fourth quadrant will be 360 minus alpha. Okay, remember the range that earlier on, the range that we need to consider for 2x minus 15? It's between negative 15 to 705. So 705 means that you need to go around the unit circle one more time. So whatever answer you get for the third quadrant, you go round one more time, so you add 360. Likewise, for your 330, you can go one more round, so you just add 360. That's not the answer yet. The final answer is you need to find the value for x. So we have 2x minus 15 equals to 210, first possible answer, 330, and then 210 plus 360 means you go one more round, 330 plus 360 go one more round. So finally, you take 210 plus 15 divided by 2, you get x equals to 112.5. You take 330 plus 15 divided by 2, you get 172.5, and so on and so forth. So these are the answers, possible answers. So how about the negative angle? Because remember the range is between negative 15 to 705. Then how about this one here? Right. If you're dealing with negative answer, for sine to be, if you're dealing with angle that's measured in the clockwise direction, for sine to be negative, then you will come from the first and the second, right? So I should have one answer for negative 30. Okay? But after solving it, you realize that the answer you get for x is negative 7.5. And that it's outside the range. It's outside the range that you need to find for the value of x. Your value of x must be between 0 to 360. So negative 7.5 is not within the range that you need to find for the values of x. Okay, as the result, we don't have to consider this. We don't really have to consider that. All right, so that's the end of the concepts on solving trigo equations. You may have to look through the slides a few times to really understand the concepts.